We have discussed about the special case of machine learning model training process, forecasting, which implies creating predictions on data that has a time series based component. So let's take a look at the walkthrough associated with the exercise in this section. Your task was to create an automated machine learning experiment that was configured to be a forecasting experiment. And first, you have selected a new data set, the training formatted data set, where you specified the URL for that data set, which Azure Machine Learning used to download the data and create the data set recording. And next, you have used the automated machine learning to configure a regression type of task using automated machine learning. And for that particular task type of regression, you have specified several settings, like for example, the threshold that was set to 0.09, the type of validation that was k-fold, the number of cross-validations, which was 5. And once all of those items were in place, you have started the run of your automated machine learning process. And the automated machine learning process has resulted in recommended model that uses light GBM machine learning algorithm with the maximum absolute scalar approach for scaling the values. And also, as you can see, the metric, the value of the metric that was recorded for this particular run was 0.04, which was below the threshold set that was 0.09. Because of the primary metric that was used, the normalized root mean squared error, basically the smaller the value, the better it is. So once the metric was below the threshold, the process has stopped. And I would just like to note here that we have used this specific threshold of 0.09 just to make sure that the automated machine learning process does not run for a very, very long time. Actually, as you can see here from the list of models that have been tested by the automated machine learning process, the very first model actually hit the quality bar with a normalized root mean square value that was under 0.09. I encourage you to test with various values of the threshold, and if you lower the threshold, you will see that automated machine learning will try several more algorithms in this particular run. Finally, you can see that the resulting machine learning model that was obtained here has various representations for the evaluation metrics. So if you click on the visualizations task, you are able to see the predicted versus true chart, and also the true value histogram, which is rather close to that ideal bell shape that we were discussing about during the course. Also, if you scroll further down, you can see the residual histograms representation, which also has a shape that is quite close to that ideal bell shape. So your automated machine learning experiment has produced a trained machine learning model that was able to predict with decent level of accuracy values in a time series data set that was configured in the first step.